receptors, CB1 and CB2, which basically are activated by THC coming from the plant cannabis. The presence of these receptors is all over our body, mainly in the brain and the central nervous system, as well as in many peripheral organs. Now, these receptors, you and I have those receptors, are present not because they are waiting for us to use cannabis, but because the body produces endogenous compounds, which were also identified by Raphael Mishulam and termed as endocannabinoids. Endocannabinoids, the two main endocannabinoids are anandamide and 2-AG, that basically activate and stimulate the cannabinoid receptors, CB1 and CB2, in a similar fashion as THC does it, although the structure of this compound is totally different. And these endocannabinoids are produced by almost any cell in our body, and any organ in our body can produce those compounds. And we can find these endocannabinoids in the blood. They circulate in the blood. Their concentrations are dynamic. They are highly lipophilic ligands, as well as they come from multiple organs and they shade into the circulation. And there is a thought that endocannabinoids can be served as an indirect marker for tissue endocannabinoid tone in different physiological, normal physiological and pathological conditions. And why it is important? Because the endocannabinoid system is one of the main endogenous systems that regulates our physiology, such as the respiratory system, the digestive system, the endocrine system, the musculoskeletal, just to name a few. And in fact, the endocannabinoids activating the CB1 and CB2 are modulating different physiological effects, and these physiological effects that are basically highlighting this are modulating different physiological effects, and these physiological effects that are basically highlighting this are modulating slide can be also modulated by cannabis or THC coming from the plant. So let's can be also modulated by cannabis or THC coming from the plant. So let be also modulated by cannabis or THC coming from the plant. Let me take you into more specific effect of cannabinoids. And we can differentiate the central effect of cannabinoids and the peripheral effects of endocannabinoids. In fact, CB1 receptor is the most abundant receptor in the human brain, and it is present in different parts of the brain, for example, in the hypothalamus. And if we consume cannabis or activating the CB1 receptor endogenously by endocannabinoids, it may induce an increase in appetite. But what happens if we do the same activation of the CB1 receptor in another brain area, for example, in the brainstem? Then it will induce nausea relief, it will lower blood pressure, lower pain, spasticity, and tremors. If we do the same activation of CB1 receptor in the cerebral cortex, it will change our memory, it may induce hallucinations, and of course altered our consciousness. If we do the same in the hippocampus, it will induce memory impairment, and if we activate the cannabinoid receptors in the cerebellum, it will induce loss in coordination. And again, if we do the same in the amygdala, which is another brain area in the human brain, it will induces changes in anxiety, panic attacks, lower traumatic memories, and decrease hostility. So you can see that one receptor that is present in different areas of the brain, and the same activation of this receptor by either endocannabinoids or phytocannabinoids coming from the plant induces different effects in the human brain. And what about the peripheral effects of cannabinoids? So CB1 receptor and endocannabinoids are present in many tissues in periphery, which means that in the gut, activation of this receptor will induce fat ingestion. If we do the same in the pancreas, it will induce insulin release. It will reduce insulin sensitivity through activation of CB1 receptor in the muscle. If we do the same in the kidney, it may induce fibrosis. And if we activate the CB1 receptor in the liver or in adipose tissue, it will increase fat accumulation in these tissues. Again, same receptor, same ligands that activate it, and we get different effects. And so we really need to understand and decide in which physiological status are we. Are we in a situation where there is an hypoactivity of the endocannabinoid tone, so reduced activation, or in a physiological state where there is an hyperactivity of the endocannabinoid tone? Because by differentiating between these two conditions, we can decide upon which treatment with cannabis or other synthetic cannabinoids can be used. For example, if we have an hypoactivity of endocannabinoid tone, we will need to facilitate the endocannabinoid system to stimulate it in order to bring it back to normal and to balance. But on the other hand, if there are conditions of a hyperactivation of the endocannabinoid tone, we will need to block it and to bring it back to normal regulation. And I would